Okay, welcome everyone. Welcome to PHL245, Modern Symbolic Logic. My name is Corey Lewis. I'll be your instructor for the semester. So we're not going to do too much today. I'm really just going to go over, I don't have 500 syllabi for you. We're just going to go over the syllabus today, which is up on QUERCUS if you want to look at it in detail, but we're going to go through it basically line by line, talk about the structure of the course, the sort of deal we're all going to be participating in, and that'll be it for today. So here's the goal. Here's the plan for this course. We're going to develop a competence with symbolic logic. That's it. That's the only goal. It's really a series of technical skills. So unlike practically every other philosophy course, we're not going to be testing you on the depth of your understanding, your rich, subtle grasp of the implications of the meaning of all this stuff. It's really just a series of technical skills, which makes this quite weird in terms of philosophy courses. Other than other logic courses, this is the only philosophy course I've ever taught that is just a series of technical skills. It's a very odd philosophy course, especially for, those of us in the kind of humanities stream. It's going to take me a little while to get used to the rumbling of the subways constantly under this, so we'll try to adapt to it. But this course is weird because people experience it in radically different ways. So for most philosophy students who take this course, hands up if you're in a philosophy course, by the way, major or minor, kind of you're in philosophy-ish. Cool, so about half of you. Hands up if you're not in a philosophy course. Yeah, like about half of you as well. Okay, so the philosophers that I talk to who've done this course find it to be one of the most difficult courses in their undergraduate degree. If you're not like in a logic stream of philosophy, this is one of the hardest courses that you'll do. It consumes more time than practically any other course, and it requires different study strategies than practically any other course. This is like, I've never imposed as much suffering on my students as I have in this course. Like you really pure agony for about half the room. For the other half of the room, this is going to be one of the easier courses in your degree. For those of you who are, for example, from a computer science or math background, like if you look up this course if you Google bird courses U of T, this course, don't pretend you haven't, but this course shows up, which is kind of like, it kind of hurts my feelings a bit because I struggled really hard to get through this course. This was a really hard course for me. The grade distribution tends to be bimodal, so there's a group that does really, really well and a group that really struggles. And I was, full disclosure, in the struggling group. I really had to work incredibly hard to get my B- in this course when I did it many years ago. So I'm one of those people for whom this course was a real uphill battle. It took me, I had to spend twice as many hours to get through this course as any other course that I was doing. It was the most painful. It was really, really challenging. And many of you will experience this course as really, really challenging. Many of you will float through it without trouble. Many of you, this will be the last time I'll see you until the test. You'll teach yourself and you'll get 98%. Not many of you, but there's some subset of you for whom this will be a really easy course. Because it's exclusively technical, mechanical skills that we're teaching you here. So if you're in the group that was like me, humanities people, we're really good at paragraphs and the subtleties of meaning and the complexities of the human experience. We're really good at synthesis and seeing the big picture. There's none of that in this course. There's none of that. What this course is a series of analytic technical skills. And I want to stress to you that even if your plan in life is to go on and be a synthesizer, you want to have this course under your belt. You want to be able to do the purely analytic technical side of things because then you're strong in both directions, the analytic and the synthetic. You want to have them both. For those of you who are here because it's a bird course, I don't know, read a book or something. You develop both sides of it for yourself as well. But bless you, I'm glad you're here. Welcome to philosophy. This is unlike most philosophy courses, but enjoy yourself, it'll be easy for you. So I'm mostly, because I was a person who struggled with this course, I'm going to be teaching mostly to the people who are struggling. So we're going to go kind of slow. I'm going to do my best to explain things as deeply as possible, as carefully as possible. So if you find this to be slow and tedious, I'm not teaching to you. I'm teaching to the people for whom this is a profound struggle. And believe me when I say for about half this class, this course is going to be a profound struggle. And you'll need to really like spend mostly a lot of time and a lot of practice. So the thing that STEM students are really good at is devoting lots and lots of time to practicing technical skills. So you got 6-8 hours a week per course of problem sets, and you just nose to the grindstone and you do your problem set. And that's a style of study that you're really well adapted to. Whereas the philosophy students are more like, you read a couple pages and you have a coffee and you go for a walk and you think. You sit there and just think and stare at a window and chew a pencil. And it's also an important kind of work, but it's different than the kind of work that you're doing here. The kind of work here, you're not doing the work unless you're actually practicing the skills. Sitting and thinking about it is not doing the work. Only practice, actual practice, is doing the work for this class. So, just by way of warning. Okay? Okay. So, I'm going to just describe briefly, there's kind of 3-4 main skills that are going to run throughout the course that are going to compose the main body of what we're going to learn here. So I'll briefly describe these now and a little bit about their interrelations, and then we'll get into the syllabus stuff. Okay, so symbolization. One of the, symbolization and derivation are probably the bulk of this course. Symbolization is taking a natural language sentence and turning it into some symbolic sentence. So suppose we've got the following. And by the way, all these slides are up on QUERCUS now. I'll post all of the slides before class, every class. So if you're frantically writing this down, what's on the slide, you don't have to. Also, I am recording this. One of these microphones is to amplify my voice, and one of it is to record it. And I'm going to post the recordings on QUERCUS. So my voice over the slides. So all of this will be available. I'll post it to YouTube for you to review, and maybe if you didn't make it to class one day, to watch it from scratch. So all of this, to try to provide as much material as possible for you to study from. Okay, so translating symbolization, translating everyday sentences into symbolic notation. So suppose I wanted to symbolize the sentence, it's not the case that if it's raining, you don't have to come to class. It's a true sentence, by the way. If it's raining, you still have to come to class. Yeah? Okay, so the little squiggle out front is the negation sign that says not, or it says it's false that whatever this thing. And then P here represents it's raining, and Q represents you have to come to class. So it says it's not the case that if P, then not Q. Okay, I'm not actually teaching you this right now, so if this is not making sense, that's fine. Just this is the kind of thing that symbolization is, where what we do is we take a sentence, break it down into its parts, and represent formally how those parts are related. Okay? So symbolization, we're going to do a lot of this. Now, what you can do with symbolization is check whether your arguments work or not. So here's an argument. So this is from the textbook that our textbook is based on, the Kalish text from 1964. Here's an argument. If Alfred orders champagne, then so does Alonzo. And if Kurt orders champagne, then so does Alfred. Either Alfred or Kurt, but not both Alonzo and Kurt, order champagne. Therefore, both Alfred and Alonzo, but not Kurt, order champagne. Okay, so the first couple of sentences are premises. They are things that you're being offered as reasons to believe the final sentence, which is a conclusion, right? So this is an argument. An argument is premises offered in support of a conclusion. Now, looking at this argument, you might have feelings about it. You might think, oh, that looks like a good argument, or oh, that looks like a bad argument. Those feelings are fine and good, but they're not a proof that this is a good argument. So, how would we prove that this is a good argument? This is, in fact, a deductively valid argument. That is, if those premises are true, then the conclusion is guaranteed to be true as well. Okay? But just looking at it, it's hard to say why that should be the case. So what we can do is take these sentences and symbolize them. So suppose that we symbolize Alfred orders champagne as P, Alonzo orders as Q, and Alfred orders as R. Sorry, Alfred is there Alfred is there twice, and Kurt orders champagne as S. Okay, so having symbolized, we can then symbolize the premises. So if P then Q, if S then P, P or S, not Q and S, therefore P and Q and not S. Okay, so really don't worry about the details here because I haven't taught you what these connectives are or how to symbolize things or any of this. I'm just trying to give you the flavor of the skills that we'll be learning. So suppose that we've symbolized our sentences in a way that makes sense. These P, Q, R, S are supposed to be sentences that could be true or false. And then on the left, we've got not just those sentences, but connections between sentences. So P arrow Q says, if P is true, then Q is true as well. So if Alfred orders champagne, then Alonzo orders champagne. And recall that that's what we had in the last slide. If Alfred orders champagne, then Alonzo does as well. So we've got these premises leading to this conclusion. Now, we've got it in a form where we've got the kind of logical structure of the argument. And what we can do is what's called a derivation. So here's the other major skill that we're going to be learning this semester is derivations. This slightly, oh, great, okay. I see. The projector projects larger than the screen. Good to know. Okay. Good to know. Okay, so derivations are proofs that an argument is deductively valid. That's what a derivation is for. That's what it does. So if we start, see the very top line, those are our premises that we pulled out of that argument. Those are symbolizations of those premises. And then we show that the conclusion is true. So we get to, we move step by step, showing that the conclusion is true based on certain rules of inference. And you can't really see the rules of inference here because of the projector, but so each of these things that are on the right are rules of inference guaranteed to be truth preserving. That is, if the thing that you plug into the rule is true, the thing that the rule spits out is guaranteed to be true as well. So we'll learn a bunch of rules for manipulating symbolic sentences that preserve truth. And if you can get from the premises to the conclusion in a truth-preserving way, then what you've demonstrated is that the premises, the truth of the premises, guarantees, absolutely guarantees the truth of the conclusion. So that's what a derivation is. It's checking, it's a way of proving beyond a doubt that if the premises are true, the conclusion is true as well, and therefore the argument is sound, or valid, sorry. The argument is deductively valid. We'll talk next time about what validity means exactly. There's a technical definition, but basically it's checking to see whether the argument works properly, okay? So the other major skill, the other main skill that we'll be learning through this semester is derivations. And this derivation is in Logic 2010, which I'll talk about shortly. Okay, so before the first test, the only things we're going to learn are symbolizations, derivations, and these things, which are truth tables. So a truth table is another way of checking the status of an argument. An argument can be valid, meaning that the premises guarantee the conclusion. It can be invalid, meaning the premises don't guarantee the truth of the conclusion. It can be tautological. A sentence can be tautological, meaning it's guaranteed to be true. It can be contradictory, meaning it's guaranteed to be false. So a truth table is a method of checking whether an argument or a sentence has those properties. So if you've got an argument, for example, and you think it's not valid, your inability to create a derivation that shows it is valid isn't really proof of it being invalid. You could just be bad at derivations. A truth table is one way of showing for sure that an argument is invalid. So we've got derivations that can prove validity. We've got truth tables that can prove invalidity and a few other properties. Okay? We won't spend a ton of time on truth tables. Once you've got the skills of symbolization and derivation, truth tables are fairly straightforward. But up to the first test, those are the 3 skills that we're going to learn, and that's it. As of the second test, there'll be a few more things. After the first test, so what I just showed you was called sentential logic. That is the logic of sentences, where P represents a whole sentence. After the first test, we'll move on to a slightly more advanced form of logic called predicate logic. And in predicate logic, we get a little bit deeper into the content of sentences. So in this case, we've got a sentence that says, everything that is gold is metal. In sentential logic, you would say P. You'd represent that as P or something. It doesn't really tell you much about the internal workings of the sentence itself. In predicate logic, we can say something more refined. We can say this upside down A says for all. So for all things in the universe, for all things X, if X has the property of G being gold, then it has the property of M being metal. So that sentence there, that upside down X, GX, MX says, for all things in the universe, if it's gold, then it's metal. Okay, so predicate logic will give us a more fine-grained approach to the structure of our claims. And then we can check arguments in a deeper and more complex way. Okay, so that's after the first test, predicate logic. And then we will, after the second test, so we'll do predicate logic for the period between the first and second test. After the second test, we'll start doing what's called multi-place predicate logic. That is the logic of things like relations. So if you wanted to represent Andrea is taller than Bill, then now we've got this 2-place relation, right? So T is the property of being taller than, and T bracket AB says A has the property of being taller than B. Stuff like this. Okay, so this is just kind of layering complexities on the original predicate logic. Yeah? Okay. And then finally, we'll do what are called invalidities and expansions, which are kind of the predicate logic equivalent of truth tables. That is, we're going to learn how to prove that an argument in predicate logic is invalid. Those are invalidities. So this is once again, we'll do derivations in predicate logic, single place and multi-place, that are proofs. You can prove an argument is valid, but using derivations, you can never prove that an argument is invalid. Using invalidities, we can prove that an argument is invalid. And expansions are a way of helping us do invalidities. So, and those will be the final skills we'll learn at the end of the course. So, that was a whirlwind tour through everything that we're going to learn in the course. I don't expect you to have picked up much of that. I just want to sort of like briefly expose you to this. A quick emotional note here on things that might be happening in your body and mind at the moment. Many of you have math panic. Math panic. You see something that looks like math and you freeze up, and you can hear your 5th grade teacher yelling at you, right? Or your parents being mad at you for doing badly on a test, right? Many people have a kind of profound emotional reaction to seeing things that look like math. And if you're in I don't think that the STEM people, I don't think you STEM people are having this at the moment. Probably you're fine. But for those of you in the humanities, you thought you left math far, far behind, and now it's coming back for you like a nightmare from your past. I promise you it will be okay. I promise you that this is not math, by the way. This is not math. This is something different. This is about sentences and arguments, which you know, which you're familiar with. And it looks scary until you get into it. So you're not going to, we'll be moving slowly, we'll be moving step by step. The first parts will not look scary. So the first couple of weeks will be relatively sane and pedestrian, and hopefully we'll just sort of slowly ramp up the complexity till you're at this stuff, and at the end of the semester, this will look fine to you. This will not induce panic. This will be a normal, reasonable thing to be looking at, okay? So don't succumb to math panic. You're gonna be okay, all right? Your 5th grade teacher can't hurt you anymore, all right? Okay. So, all right. So this is roughly the schedule. I don't expect you to actually be reading this right now, but I just want to show you what's on the syllabus. So the syllabus is up on QUERCUS. QUERCUS is live. You have access to this online. So every week there's the following things. Every week there's a topic and there's some chapters from a textbook. So the textbook associated with this course, it's called we call it affectionately the Terry text. It's a book by Terry Parsons, and that's up on QUERCUS as well. So the Terry text comes with Logic 2010. It's sort of built in. The program that you'll be working with is kind of like meshed with this textbook. So for each meeting of this class, there's some bits of the textbook that would be helpful to read. Now, I'll be going, it's not strictly speaking required reading. I'll be going over everything that you need to know from the textbook in class. But it's nice to have an extra set of, it's nice to have somebody else explain it in a slightly different way. And there's a bunch of extra exercises. If you're like, I want more exercises, there's some exercises in the book. So it's a nice resource. I do recommend, if you're looking to use all of the resources available to you, that you take a look at the Terry text. You'll also see that there are exercises, weekly exercises, and we'll talk about those shortly. Okay, so this is all in the syllabus. Okay. Are there any questions at this point before we move on to the sort of course structure stuff? Okay, let's talk about the course structure. There are not that many elements that your mark is based on. There are 4 things. Well, the weekly exercises are 10 things, but they're kind of one thing. So there's weekly exercises. They don't start this week. They will start next week. And those will be done on Logic 2010. I'll talk about them shortly. There's 2 tests and an exam. Okay? So let's talk about these things one at a time. So the weekly exercises will be completed using this program, Logic 2010. There's a link for downloading it on QUERCUS. It's free. There's nothing you have to pay for to participate in this class. And I'll post these exercises on Monday. They'll be due, that should say Saturday at 4 p.m. Okay? So the due dates are all up on the syllabus. Now, these exercises are not, they should not stress you out too much. The structure of them is such that you can try them as many times as you want. This isn't like try it once and then you get whatever mark you get. You can try them again and again until you get the mark, right? Until you get them all done. You can try them at you're writing this on a program on your computer, so you can do it from home, you can do it at your leisure. And they'll all be sort of like stuff that we just learned that week. So you'll always be fresh on the things that you're supposed to know to do these exercises. So here's the structure. It's not that hard, it's not that convoluted, but this is what you need to know. So I'll post these exercises on QUERCUS. So the questions you need to complete will be posted on QUERCUS, but you complete them in Logic 2010, the program, which you will have downloaded and will be on your computer. So there's a program that you'll download onto your computer. You complete the exercises in Logic 2010, submit them in Logic 2010, yeah? And then you can confirm that you have submitted them on a website, the Logic 2010 website. The catch with all of this is that the instance of this course hasn't been generated on Logic 2010 yet. But let me show you basically what this looks like. Okay, so here's Logic 2010, the program. And these are the kind of like main things that you can try. There's derivations. And what I'll do is I'll assign some questions from this list. So when I go to select, I'm going to select my problem. There's a long list of problems. There are many, many problems to choose from. I will post a few of them that are the exercise. And then you'll do them. You'll go into one of these things and complete the exercise. Some of them are, as you can see, fairly simple. You'll do these things, and then you'll click Save, and then you'll click Submit. And you'll type in your password, and it'll tell you which course you're in, and then you click Submit again. All problems are so you want to see this screen. So this screen shows me that you have submitted your exercise to Logic 2010. Okay. Now to confirm that you've done that, you go to this website, the Logic 2010 website. There's a link to it on QUERCUS. You'll go to your version of the course, and it'll show you whether or not you've submitted these properly. So you can see I've done not very well on this exercise. I failed to submit 1 to 10. I submitted 11. I submitted these late. So you can see NS eval under this one. It says whether you submitted it or not. C is complete. L is late. NS is not submitted. Okay, so it's going to be up to you to make sure that you have submitted these. Completing them is not enough. Just having completed it doesn't get you the mark. What does is submitting it after you've completed it. Okay, and you can check whether it's gone through on the website. The catch is the version of this website or the version of this course has not been generated in the Logic 2010 system yet. I submitted a request in August of last year, and then I got an email from the guy on New Year's Day saying, hey, do you want a course this year? And I said, yeah, I really do. I haven't heard back from him yet. Hopefully it should be soon. I would just like to point out that Logic 2010 is a wonderful, wonderful program, and I'm super grateful that you all get to use it as a tool. It is extremely useful for learning logic. It is free. It's not a commercial software, which is why I can't send in a customer complaint, because I'm not a customer. This person it's a guy from UCLA, David Kaplan, and he's giving us this program out of the goodness of his heart. So hopefully we will have a version of this course that you can sign up for in the next couple of days. I'll send out an announcement on QUERCUS as soon as that happens, and you can sign up for the 2019 version of this class. So don't worry about this just yet. I just want to show you the basic system, and I'll let you know as soon as we're ready to sign you up for this, I'll let you know. Okay? It really is a wonderful, wonderful program that's incredibly helpful for learning this stuff. Kind of too helpful in a certain sense, because it's like logic training wheels. So Logic 2010 does about half of the work. If you're learning to do a derivation, Logic 2010 does about half of the work for you. So you tell it what rule you want it to apply, and then it applies the rule and tells you what the output of the rule is. But that's not what's going to happen on the tests and the exam. On the tests and the exam, you're going to write down what the rule is, and then you're also going to write down what the output of the rule is. Right? So Logic 2010 is really helpful for kind of like guessing and checking. It tells you whether you got it right or not, whether the rule applies or not. So it's really helpful for the learning process, but you're going to want to do a lot of practice with pen and paper because people can become dependent on it. So last semester I had a whole bunch of people tell me, you know, I practiced and practiced, and then I got onto the test, and I just forgot how to do derivations. Totally forgot. And I asked, did you do all your practicing on Logic 2010? Yeah. Okay. That's the problem. So you cannot completely rely on Logic 2010, although it's incredibly useful to have as part of your learning process. You need to do both Logic 2010 and pen and paper practice. The pen and paper practice is the more important one because your tests and your exam are going to be pen and paper. Okay? Okay. So, I'm going to post the exercises at the beginning of the week on QUERCUS, so you'll know which questions are part of the exercise. They'll also, which part of this will also show up in the Logic 2010 website, so you can go there and see what's in the weekly assignment as well. Then you're going to complete them in the Logic 2010 program. And what I'll do in class as we get closer, I'll show you the commands for Logic 2010 that are relevant for that week's exercises. So I'll do Logic 2010 demonstrations as we go. It's not a super intuitive program, and it reminds me very much of the first computer I ever used, which was a Commodore 64 in like the early 80s. So it's not the prettiest program. It is not the most intuitive program, but once you get it, it's reasonably straightforward, and it's incredibly useful. And then you have to confirm that your submission was submitted on the Logic 2010 website. I'll be merciful for the first week or so. You say, oh, I completed them, but I didn't submit them. Many of you will say that to me. And the first week I will say, okay, I believe you. And the second week I will say, too bad. Okay? So you need to be able to confirm for yourself whether you've submitted these things or not. Okay. And I have to say, I have to be mildly draconian about this. Late exercises will only be accepted with a medical note or by getting your registrar or accessibility services to get in touch with me. Okay? There's basically no late policy. If you miss the deadline, you miss the deadline unless there is some mostly medical reason why you couldn't submit it on time. This is partly because the administrative task of dealing with 500 students is large, but more from your perspective, you really don't want to fall behind in this course. You really don't want to fall behind in this course. If you space out for a couple weeks in this course, you're going to be in trouble, like serious trouble. And what happens is every skill that we learn is necessary to learn the next skill. So this stuff from week one, the stuff that we're learning is going to be foundational to doing the next steps. And if you miss out on that foundational stuff, the next step isn't going to make any sense to you. You're going to be struggling and you're not going to understand why. So not missing a step is more important in this class than any other class that I've ever taught. Again, STEM people probably are very used to this, where skills build on skills build on skills. So partly, I just don't want to have a million requests for extensions, but mostly this is to keep you on track. You must stay caught up with this course. If you fall behind, it gets worse and worse for you. So don't fall behind is my recommendation. And this is meant to enforce that. Don't fall behind. Okay. There'll be 2 tests. Each one will be 2 hours. And I've put in requests for rooms other than this, because this is not a nice room to write a test in. Hopefully the exam center. We will see. And we'll be writing during regular class times. Continuing on the theme of being draconian, I'm not going to be able to help you. If you've taken this course as a conflict with another course, I'm not going to be able to help you. Official U of T philosophy department policy is we don't accommodate students who have taken a conflict. So if you email me and say, I got another midterm during the same time as your midterm, can you help me? I will have to say no. And I mean, one of the important reasons why is because there's a wait list for this class that is hundreds of students. Does anybody know how long the wait list is right now? Like typically it's hundreds of students long. Last I heard, the wait list for this instance of this class was about 200 people. It usually clears, like usually there is a massive dropout in the first couple of weeks, and then lots and lots of people who are on the wait list get in. But because there's such a long wait list and there's a chronically long wait list, the idea of accommodating people who've taken this as a conflict seems like just trading off, like there's two groups of students in need, and one of you are like following the rules and one of you are doing something you're not supposed to. So I have to choose one of you to try to help. I'm going to try to help the people who are following the rules, if that makes sense to you. So if you've taken this class as a conflict and you have conflicts with the midterms, I recommend you drop the class. That's all I can tell you. Especially because if you have a conflict with your exams, there's nothing I can, even if I was highly motivated, there's nothing I can do to help you. The exam scheduling is entirely beyond my control. I can't help you at all if you have an exam conflict. This exam is worth 40% of your final mark, so you don't want to miss it. And I am administratively powerless to help you if you have an exam conflict. So I strongly recommend you don't take this course as a conflict. Okay? Okay. If you miss a test, I need you to get in contact with me right away, within 24 hours. Unless you're like in a coma or something, I expect you to get in touch within 24 hours or you will lose your right to write a makeup. And I'm going to need some kind of medical documentation or talk to your registrar who will talk to me. This is a policy in place because I need to run the makeup test fairly quickly because the makeup test will be substantially similar to the test, and I want to be able to post the answers to the test fairly quickly after the test. So for the sake of all of your fellow students, please get in touch very quickly. We'll set up the makeup test as soon as possible. And if you don't, you kind of miss your chance. All right? Okay. There will be an exam, 3 hours, standard procedure, time and location to be announced. And I say the exam is cumulative, but it's cumulative in a funny sense. It's cumulative in the sense that the skills that you need to write the exam are skills that we've been developing all semester. So the exam will be, I know this doesn't mean all that much to you right now, but the exam will be almost exclusively symbolization and derivation in multi-place predicate logic. So I'm not going to go back and ask you questions from the beginning of the course, but the stuff at the beginning of the course is necessary to do the stuff in the middle, and the stuff in the middle is necessary to do the stuff at the end. So in a very important sense, the exam is cumulative, although it will be primarily testing the stuff that we learned at the very end. So there's that. Yeah? Okay. And if you miss the exam, I'm literally powerless to help you. There's nothing I can do. If you miss the exam, you talk to your registrar. And same goes for stuff like if you don't have an actual conflict, but if you have an exam in Scarborough and then my exam is like an hour later, your registrar can help you with that. So that's the kind of situation that they are like set up to accommodate you somehow. So if you have a situation like that, or if you miss your exam for some reason, your registrar is the person to talk to. Okay? Good? All right. So let's talk a little bit about the resources that you have available to help you get through this course. So there's no tutorials. There's no fixed tutorials for the course. What there are is what's called the Logic Lab. So the Logic Lab is a kind of voluntary drop-in sessions where you can come and get help with your weekly exercises or anything you're sort of like want help with in the course. They'll be Thursday, Friday afternoon. So this class is Monday, Wednesday. The exercises are due on Saturday. So they'll be on Thursdays and Fridays between when you learn this stuff and when you have to submit it. They're run by undergraduates, actually, who did extremely well in this course in previous years. The Logic Lab is there's not a lesson plan there. So if you go there, it's not like the TAs are going to say, okay, everyone, here's our lesson for today in Logic Lab. It's just them sitting in a room, and what you're going to do is bring your laptop or some exercises, and they're going to help you work through it, right? So there's no like structured lesson being presented in Logic Lab. It's just a space where you can come in, and what typically happens in a Logic Lab actually is students help each other largely. So there'll be 1 or 2 TAs in there going around trying to help as many people as they can, but it's as much a peer helping space as somebody helping you space. They're extremely helpful. People report them being extremely helpful. So strongly recommend that you go to the logic labs regularly. Yeah. And again, we put in, keep an eye on QUERCUS. We'll announce the times and locations soon. Roughly speaking, Thursday, Friday afternoon, and they'll be in the Jackman Humanities building. That's the building, it's at Bloor and St. George. So where they'll be in the philosophy department at Bloor and St. George. Yeah? Questions about that? Okay. Another thing that you have available, we're going to have a discussion board on QUERCUS. So you are highly encouraged to ask and answer questions on this discussion board. I'll be on there. At least one other TA will be on there trying to answer your questions. And you're highly encouraged to ask and answer any questions about about anything in the course, but especially about the weekly exercises. So you're not facing these weekly exercises alone. You don't have to sort this out by yourself. I know the standard procedure in university classes is that it's all your own independent original work. The weekly exercises for this course are an exception to that rule, okay? So you are highly encouraged to say, I'm having trouble with derivation 1.024. I got this far, somebody please help. And somebody will be there to help you, okay? And then you will type in the answer, submit it, and get credit for it, okay? So it's not the case that you have to do this all by yourself. In fact, I recommend that you don't try to do it all by yourself. I mean, you take a shot at it, and then when you get stuck, you probably will get stuck, then ask for help, either in the logic lab or on the QUERCUS discussion board. I want to encourage a kind of norm of behavior on this discussion board. Obviously, we're going to be civil. The sort of like code of behavior for University of Toronto applies to the discussion board as well. So like be nice and polite and all that stuff. Also, I want to recommend the following. Ask a specific question and give a specific answer. So don't just say, I don't know how to do this problem. Yeah? If you say, I don't know how to do this problem, they don't know how far you got into the problem. They don't know where you got stuck. Yeah? So do the following. Say, I got to this line in this problem. Maybe post a screenshot. Yeah? And say, now what do I do? And somebody will, hopefully, the nicest thing you can do for somebody is not to give them the whole rest of the answer. Although the easiest thing to do is just to give them the whole answer. The nicest thing you can do is to just give them the next step. Because the point of this is not to get the answer. The point of this is to practice. Right? And just having the answer is not practicing. Practicing is getting you unstuck on that one bit that you couldn't work out and then doing the rest yourself. So highly recommend that you go there for help and to help other people, because teaching people is the best way to learn something. Right? So that's good practice for you as well. And ask specific questions. Ask about, how do I get past this part of the derivation? Or why is the symbolization this way rather than that way? And give people specific answers. To get past this line, you do this, or this is why it's a conditional rather than a conjunction, or whatever the problem is. Okay? Okay. There's also the readings. There's the textbook, as I mentioned. We call it the Terry text because the actual title is An Exposition of Symbolic Logic by Terence Parsons, which is a bit of a mouthful. But it's up on QUERCUS now. It's sort of embedded in Logic 2010, and it's tightly integrated with the problems on Logic 2010. So the whole course is roughly structured around both this program and this textbook. The order in which I'll be presenting the skills in the class is the same order as in the textbook, and the order of skills that are tested in Logic 2010 are the same as in the textbook, and the same as in this class, or in the lectures. So it's all an integrated package. So reading the Terence text, the Terry text, the Terence Parsons textbook, is a nice addition to lectures and practicing Logic 2010. Yeah? Okay. I will try my level best to respond to any email sent to me within 24 hours, Monday to Friday. Weekends, I'll try, but I sometimes have things to do on the weekend. The trick is I can't teach you logic via email because there are 500 of you. If you have a logic question, please put it on the QUERCUS discussion board, and I'll be there. I will be there to try to answer your questions on QUERCUS, but if you have this question, the chances are that many of your fellow students also have this question. So it would be a really energy inefficient way for me to try to help you if 50 of you have the same logic question and I get 50 emails and answer 50 emails. If you put it on logic or the QUERCUS discussion board, your question can help a bunch of other people as well. So I may or may not, if you ask me questions that are on the syllabus, I may or may not respond. I will definitely be unimpressed. Yeah? Okay. Office hours, Thursday, 3 to 5. I'm in the Jackman Humanities Building, 5th floor, room 538. And similar to email policy, I don't think it's reasonable to treat this as me doing one-on-one logic tutoring with you. Mainly because there needs to be a time and place where you can come talk to me about issues other than learning logic. So if you've got an administrative question, or like you're in some sort of trouble in the course, or something like literally anything other than the nuts and bolts of logic, there needs to be somewhere. You don't want to get to my office and there's a lineup of a dozen people asking the difference between modus ponens and modus tollens, and then you've got this like, oh, my mom just died and I need to sort some stuff out. Like there will be a bunch of people with serious problems that need to be addressed in a timely fashion, and those people don't want to have to wait in a long lineup with people who just want advice on the basics of doing logic. So the appropriate place to look for one-on-one personal help on the nuts and bolts of learning logic is the logic labs and on QUERCUS. So those are the places to go for that. Email and office hours, I'd like to keep open as a channel for communication on all other topics, because again, there's quite a number of you. There will be a bunch of people who have to talk to me one-on-one about stuff that's important. So I need for them to be able to kind of walk right in and be able to talk to me. Is that fair? Okay. Okay. So actually, before I do this, is there any questions so far? I mean, this is the last slide, I'm almost done, but questions about the content structure? Yeah. A what? You do not get a formula sheet. The question is, do you get a formula sheet? You do not get a formula sheet. Sorry. But I bet you're a STEM student. Where there's, how many formulas would you say you need to know in a typical class? Like dozens? Okay, so this whole course, there's maybe 24 rules you need to learn. The whole course. So the tables are relatively straightforward. Like, honestly, there's maybe 6 connectives that you need to know how they behave, and you need to know how they behave, and they're the same connectives in symbolization, derivation, the tables, the invalidities, and expansions. So you'll have those down pat. There's maybe 15 rules in the whole course that you need to know, and I won't give you what the rule is, but I'll give you the names of all of the rules. So there'll be a list for the derivations. There'll be a list. Here are the rules you're allowed to use. I'll give you the names of the rules. It's up to you to remember the rules. So it's well within your capacities to do that. Yeah. Other questions? What do you got? What would you like to know about this course? Yeah.
You just mentioned that we can try for multiple times the weekly exercise. So
that's right.
If we fail twice or several times, is there any discount for mark?
Does it what?
Is there any discount for mark?
No. So the structure of these, the question is, if I'm doing the weekly assignment, if I don't get it 3 or 4 times, does that affect my mark at all? The answer is no, because on Logic 2010, you just do it until you get it. You can fail to answer the question 100 times, and then on the 101st time you get it, and then it's marked as complete, and then you click submit and you get full marks. So there is no limit to how many times you can try. There is no limit to how long you have to try it, other than like the weekly deadline. So these are relatively low pressure situations to be learning this in. Yeah. Yeah. So the question is, do I have any policies in conjunction with accessibility? I work with accessibility every semester. I don't know. I find accessibility services to be one of the most humane things that this meat grinder of a university does. If you're not registered with accessibility and you have any inkling that you should be, you should sign up because they can help you. And I'm very happy to. They're kind of an administrative excuse for me to be nice to you. And I wish I could be nicer to you, but in general, I can't unless I get something from your registrar or from accessibility or from a doctor. Those are my excuses to be nice. So talk to them, get official help. Otherwise, it's like, what I can't do is leave it up to myself, where you tell me a story via email about how hard your life is, and then I make a judgment call. Like we can't do that. But if somebody from accessibility services says this person needs this, then easy. That's easy. Done. So talk to accessibility. They can get you extensions. They can get you extra time to write your tests. It's a good deal. And this, I mean, student stress levels are at the highest I have ever seen them. Y'all need help. So go get it. Get help. For real. Okay. Okay. Other questions? Yeah. Yes. So the question is, if you're on the wait list, is there any way to access QUERCUS? If you email me, I can register you as a guest, and then you'll be on. There's not much really to do this week. I think what the wait list ends when, like, a week or two. So there's not much that's urgent this week for you to get on. So nothing bad will happen. But if you want on, email me and I'll add you as a guest to QUERCUS. What else we got? Okay. My advice to you are these three things. Practice is the only way to learn this stuff. Stay caught up. Don't fall behind. Make time for this course. If you're not used to doing problem sets, you're going to have to make extra time for this course. And furthermore, pen and pencil first. Do this, or you'll have trouble transferring to the test. Okay. Thanks, everyone. We'll talk again on Wednesday.